When programming in Java, we want to know how can we take a complex task and bring it into a more simpler task. To do this, we use functions and methods in Java libraries. For example, when we want to take a mixed fraction and we want to put it into a more readable format, we need to be able to initialize variables, call those variables, and then use methods or functions to make the function work as expected. For example, if we were to just create a scanner input object, my main method would just run through the scanner objects, input.next in, and assign them to separate variables like numerator and denominator. Once the object is converted into these separate integers, we allow it to go into another method called mixed fractions. And this allows us to try accept a division by zero errors. I'll explain later, but when a fraction goes through these statements, the numerator and denominator are checked to be within range. So once they're within range, we have the difference, and we want to continue to calculate that difference until we finally have a numerator and a denominator that we want to use. So if we have integer I and we go from 0 to the denominator, we're able to use each fraction to compute the fraction. And once we compute the fraction, we're able to know what iterator I we need to have in order to split it into a whole number and to a separate fraction. So we continue to check the fraction, and I use check difference to check these differences. Once I reach my main algorithm right here, which is left numerator equals denominator modulus denominator, we're able to find that extra fractional part, which is the max numerator that the fraction can hold. So then we want to simplify it. So say if we have 2/6, that means that the max numerator is 2. So if we want to simplify it to a much smaller fraction, like 1/3, we need to find a simplified numerator. And to do this, we just take the integer I and we find the lowest numerator that it can have. So first we start with the denominator, we simplify the denominator, and we find that it's 3. Then we can just solve for the simplified numerator. We end up with 3 different cases in which the numerator is greater than the denominator, the numerator is less than the denominator, or the numerator is equal to the denominator. So each of these cases deals with improper fraction being the first, second is the proper fraction, and then finally is the improper fraction that it can be reduced to a regular integer. So we just need to cast to integer. Using the int type, we're able to reduce, for example, 6 over 2. This is an improper fraction, and it correctly assumes that it can be reduced to 3. So my fraction resulted in a success. But what if we want to have a larger numerator and a much more odd denominator? Well, to do that, the program finds that 140/19 is an improper fraction, and its a mixed fraction is 7 plus 7 over 19. This is correct also. But let's say that we want to find a more different type of fraction in which we can reduce the actual fraction. Well, this type of program doesn't really simplify it instantly because the program is not meant to do that. It's meant to just find the max numerator, which is 2. But if we add a different method, a different algorithm, we can continue to test if my program works by simplifying it numerically. So if we have 3 plus 2 over 6, the numeric method would be just to solve for the numerator and just keep the denominator from changing. So that'd be 1 over 3 instead of 2 over 6. The program accurately deduces this, and thus we're able to make a program that works for all cases.